Now for the next part, we've got to find the number of years when the population of rabbits, that's P, exceeds 1,000. So basically all we need to do is say that when P is greater than 1,000, we can set this value, which is P, to be greater than 1,000. So therefore we have 80 multiplied by e to the 1/5 t has to be greater than 1,000. Now to solve this inequality, what I'd want to do first of all is to divide both sides by the 80, get rid of that. And so if we divide both sides by 80, we're going to be left with e to the 1/5 t here is greater than 1,000 divided by 80. Let's just put that down as 1,000 over 80. If you get on your calculator, you'll find that 1,000 divided by 80 is going to be 12.5. So that's e to the 1/5 t is greater than 12.5. Now I need to get to this power here, and what we can do is we can take natural logs to both sides. And if we do that, we have the natural log of the left hand side, e to the 1/5 t, is greater than the natural log of the right hand side, 12.5. Now you should know the power rule for logs. Let me just outline it over here on the right. Okay, if you're unsure of this, just go back to the log tutorials on my site. Okay, but you should know that if you've got the log of anything, let's say a to the power n, in any base whatsoever, let's say base c, then this is identical to n times the log of a in base c. You can just bring that power out to the front. So if we did that here, we're going to have 1/5 t then times the natural log of e, and that's going to be greater than the natural log of 12.5. Now, what is the natural log of e? Well, it's 1. You should know that any number to its own base is always 1. The natural log of e, let's just put it over here for you, natural log of e is going to be 1, since e to the power 1 equals e. Okay? But that's the one that you should know. So what we've got here is 1/5 t then, times 1 is just going to give 1/5 t, is greater than the natural log of 12.5. To get t, all I need to do is times both sides by 5, and we have t is greater than 5 times the natural log of 12.5. Do this on any calculator and you'll end up with t being greater than 12.628 and so on. Now they wanted the least number of years that the population would be greater than 1,000, so if we're giving this to an integer value, we can say that therefore the least number of years, okay, it's got to be 13. Alright, so least number of years equals 13. And we'll just finish that off by saying for population, okay, to exceed 1,000. Alright, now I've done quite a lot of working here just to demonstrate this. I'm sure if you're up to speed you could cut out many of these stages. A lot of you who are familiar with logs would most probably have a line like this and just take logs to both sides to base e and just go straight down to the fact that 1/5 t is greater than the natural log of 12.5. That's fine if you want to do that. As I say, I've just been putting in extra lines just to slow the pace of the problem, just so you can see what I'm doing. Okay, well that's the end of part B.